Hello people, welcome to the first video in my tutorial on generating sound with C++ and SFML. So first let's take a look at SFML. It is a simple and fast multimedia library. It is cross-platform capable. So you can use Windows, Linux, or Mac OS. And it makes it very easy to do things like draw windows, draw shapes, text, deal with mouse, keyboard, and joystick input, as well as doing audio. And so we're going to use this library to help with our sound generation program. A couple things to think about before we start is this tutorial is in the Linux version. So if you're using a different version, it's just a slightly different installation method. And you'll just want to go here to the Learn tab and Tutorials and look at your appropriate getting started. So you'll want to use SFML and Visual Studio if you're on Windows, or SFML and Xcode if you're on Mac OS X. However, I would recommend using Linux. The best way to do that is if you have a different operating system. Like for example, I'm actually on Windows, but I'm running Linux using VirtualBox. So I would recommend downloading the latest version of VirtualBox for your operating system, and then downloading a distribution of Linux. And the one I'm currently using is Ubuntu Mate. And so if you download this distribution, you'll be able to download the ISO and then create a new virtual machine and install Linux on there. That might take a while, so you'll want to do that when you have a lot of free time. But if you're interested in using the exact environment that I have, then that's what you'll want to use. Now let's get started. How do we install SFML on Linux? Well, if you've got an Ubuntu distribution or Ubuntu Mate, it's very simple. You'll want to go and open a terminal, and all you have to do is type in sudo apt install lib sfml dev. You hit enter and you give it your password, and that will install SFML for you. I've already installed it, so I'm not going to do it again. And that's basically how you install libsfml on Linux. So now let's get to the business of generating sound. So let's take a look at exactly what that means. So when we record sound with microphones, sound is really just pressure waves in the air, and a microphone takes those pressure waves and turns it into voltages, and the computer takes the voltage and turns it into a list of numbers. And so we can actually graph what a sound looks like. And so the horizontal axis here is time, and the vertical axis are the numbers that the computer uses. And so a sine wave might look something like this. And the way that computers do sound is they actually take samples from the microphone. So they actually take slices of the sound, and they record the amplitude of the sound at slices in time. And so what may happen is down here at the origin here, that might be 0, and so the computer records a 0. And this point in time may be 200, so we record a 200. And this point in time it may be maybe 210 or something. And so on and so forth. The computer records these numbers. and it records them at regular intervals. So and this is called the sampling rate, and so the computer records so many times per second it records the amplitude of the sound wave. And then when it goes to play a sound back in the speakers, it plays these numbers, and it uses the same samples per second or numbers per second, and it sends out those numbers, and the computer turns it into voltages, and those voltages push the microphone back and forth and create pressure waves. So that is a very brief introduction on how digital audio works. And so what we're going to do is, instead of recording sound, we're going to generate numbers and play those numbers as if they are sound. So let's get started. The first thing that we'll do is I'm actually in my workspace here. I've created a folder called sound, or directory called sound, and what we'll do is we'll go into that directory, and you'll see I've already created a makefile. I'll show this to you a little bit later, but what we are going to do right now is create a very simple Hello World-like SFML program, just to make sure we've got SFML working. So let's go ahead and do that. Let's create a main.cpp, and let's include SFML graphics, so that way we can have a window. And even though we're not going to use it right now, let's go ahead and include audio. And let's go ahead and have some foresight and include all the stuff that we're going to need. So we're going to end up using vector, and let's use the standard namespace. That makes typing a little bit shorter for some things. And create our main function, turn 0, and what we do, and what we're going to do is we're going to create a window, and then we're going to create in games what's called the main game loop, and that's what you use to draw every frame of your window. So let's first create a window. So the way we do that is we create a render window, and we set the video mode. I have an 800 by 600 window, and we'll call our window my window. There we go. Now we'll create our game loop. Even though this isn't a game, it's usually called a game loop because games use this to do their game logic every frame. So let's create a window. Let's see, while it's open, what we're going to do is we're going to have an event, and we're going to pull that event. So we'll do window.pull event, start event, and if our event type is closed, then we can close our window. And that's basically the only reason we create this whole event loop, is so that way we can actually close our application. And that's pretty much it for a simple SFML program. So let's test it out, and to compile it, actually let me show you the makefile I created. And this is the reason why I created the makefile, is so I could include the SFML modules. There are 5 different modules. I've included most of them here: graphics, audio, window, system. And the reason I included more than I need, but this just makes it safe. So if I end up using a module, it's already there for me. I've also created a flag for my C++11 because we're going to be using some C++11 stuff. And the rest of this is just a regular makefile with a single file with our main. So let's close this up and run make. And now we have a sound executable, or an executable called sound. Won't make any sound right yet, but it should create a window. So we do. This is our sound window. And you can, oops, let's see, we should be able to resize it. Got this tiny mouse. But yeah, so now we've got our window and it's working. So that we have now set up our system for our sound. So then the next thing that we're going to do in the next video is actually look into generating our sound numbers. Thanks for watching, people. Till next time.